So last night's homework was page 199, 8, 9 and 10. Right, okay, so page 199, 8, 9 and 10. And you need me to do number 8? Number 9? Do you say yes for number 9? Yeah, right, okay. So number 9, the probability that it will rain tomorrow is 1/3. So rain, no rain. Okay? So they said it's 1/3, its chance is going to be raining. So what are the chances it's not going to be raining? So 2/3. Because it's either rain or no rain. Okay? And then some fella's going to late or no late. Right? Or he's going to be late and he's going to be not late. Okay, maybe not late instead of no late. Okay? So then it says, if it is raining, the probability he will be late is 1/4. So if it is raining, he's going to be late is 1/4. So if it's raining, what's his probability of not being late? 3/4. Okay? And then it says, if it is not raining, the probability he will be late will be 1/5. So 1/5 here. So if it's not raining, what's the chances of not being late is 4/5. Okay, so that's your tree diagram. And part 2 it says, find the probability that Simon will be late for school tomorrow. So he can be rain and late, or he can be no rain and late. Isn't that right? Okay, so rain and late. So rain is 1/3, late is 1/4. So rain and late is 1/3 multiplied by 1/4, and no rain is 2/3, and late is multiplied by 1/5. Right, into the calculator with that and add them all up. So that's 1/12 plus 2/15, which is, I don't know, 13/60. Thank you. And that's your answer. Is that alright? Okay, so that was number 9. Number 10? Just draw the tree diagram. Okay. So on his way to work, Nick goes through a set of traffic lights. So he does traffic lights first. And then he goes through a level crossing. So level crossing. So we're stopping and we're going. Okay? So when he gets to the traffic lights, he's either going to stop or he's going to go. Would you agree? And then when he gets to the level crossing, he's either going to stop or he's going to go. Right? And he's going to stop and he's going to go. Would you agree? So he can stop at the lights, stop at the level crossing. Stop at the lights, go at the level crossing. Go at the lights, stop at the level crossing, go at both. Is that alright? Let's put in the probabilities. Over a period of time, Nick estimates the probability of stopping at each of these. The probability he has to stop at the traffic lights is 2/3. So what's his probability of going at the traffic lights? 1/3. Okay? And then it says the probability that he has to stop at the level crossing is 1/5. So this is 1/5. So what's the probability he can go at the level crossing is 4/5, isn't it? Okay, and it's 1/5 and 4/5. Okay, then it says construct a tree diagram, just did it. Part 2, calculate the probability that Nick will not have to stop at either the lights or the level crossing on his way to work. So that's, he wants to go and then he wants to go. So he wants to go at the lights, go at the level crossing. So go at the lights is 1/3, go at the level crossing is 4/5. Into the calculator for that and you get 4/15. Alright? Are we okay? Right, then on the next page we're doing expected value. So I asked you to do 4, 5, 6 and 7 on page 204. Right, so does anyone need me to do number 4? Number 5, no one for number 4, but someone for number 5, right? Okay. The probability, right, of getting a -2 is 0.3. The probability of getting -1 is 0.1. Probability of getting 0 is 0.15. Probability of getting a 1 is 0.4. And the probability of getting a 2 is 0.05. So, sorry? I'm recording, yes. Yeah, I remembered. So it's -2 multiplied by the probability, okay, which is minus 0.6. It's -1 multiplied by the probability, which is minus 0.1. It's 0 multiplied by the probability, which is 0. It's 1 multiplied by the probability, which is 0.4. So that's 0.4. And then it's 2 multiplied by the probability, which is 0.05. When you multiply those, you get 0.1. And you add all those up and you get that's minus 0.5. Minus 0.5, add 0.5 is 0. Have I done that right? Or is the answer 0? Is the answer 0? Minus 0.2. Have I? That's minus 0.7. Oh yeah, I just added wrong. Right, okay. So I added there and got 0. Right, so it's minus 0.2. Is that okay? That's number 5. Number 6? Okay for number 6? Yeah? Number 7? You're okay for number 7? Can you do number 7? Yeah. Okay. So it says, and list the 8 different outcomes when fair coins are tossed. So you can get a head, a head, a head, a head, a head, a tail, a head, a tail, a head, a tail, a head, 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 tail, 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 head, tail, 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 head, right, and head, head, head. Right, is that okay? That's your, oh sorry, that should be TTT, I've done sorry, that should be TTT. Right, okay, so looking at those, when you toss your 3 coins, you can get no head, you can get 1 head, you can get 2 heads, or you can get 3 heads, isn't that right? So these are the outcomes, so the number of heads you can get. So when you toss your coin, you can get no heads as in here, you can get 1 head as in this one, right? You get 2 heads as in this one, or you can get 3 heads, is that right? What's the probability? There's 8 outcomes. What are the chances that you'll get no heads? How many of those have no heads? 1, so it's 1/8, isn't it? Right. What's the probability that you'll get 1 head? How many have 1 heads in there? There's 3, isn't there? 3 out of 8. 1, 2, 3. Right? What's the probability you'll get 2 heads? 3 out of 8. And what's the probability you'll get 1 head? 1 out of 8. Okay? So you multiply the number of heads by the probability of that happening. So that would be 0, that would be 3/8, that would be 6/8, that would be 3/8. Add them all together, 3, 9, that's 12/8, and 12/8 is 1.5. Okay? Is that right? Right, that was it, was it? Yes. Right. Are we okay to move on? Or do you think you should spend another day at the expected value? Move on? Right, okay. I was hoping he'd say that. Because here's something I prepared earlier. Right, okay. So, we're moving on to Bernoulli trials. Right, that's the name of the mathematician. I think he was Swiss. Right, Bernoulli trials also, there's a binomial distribution in there as well. Right, okay. So, Bernoulli, sorry, it's all kind of a read. Bernoulli trials are repeated identical trials. So that means I'm going to toss a coin 8 times. right? I'm going to try and score a basket 10 times, right? So I'm going to do the same thing a number of times, okay? So I'm going to toss a coin 10 times in a row. I'm going to throw a dice 10 times in a row, right? I'm going to, I don't know, pick a ball out of a bag 10 times in a row, right? Okay? So Bernoulli, sorry, it's all after being rubbed out now.
Call out the heading.
It's Bernoulli Trials Binomial Distribution. So it's BERNOU, I better spell him right. I think I've spelled him wrong there. There's no I. NOULLI. So, right, I put in an extra I there. So BERNOULLI. BERNOULLI. So, and the first sentence, I forgot to put it in, so I had to go back and squash it in. Bernoulli trials are repeated identical trials, right? So that means you're going to do the same thing a certain number of times. So you do the same thing 10 times, you do the same thing 5 times, you do the same thing 100 times, whatever it is. Okay? So Bernoulli trials are repeated identical trials. Okay? In order for it to fit the criteria to be a Bernoulli trial, right, each trial can have only 2 outcomes, success or failure, as in tossing a coin can be part of a Bernoulli trial because you either get a head or you get a tail. There's 2 outcomes. Having a baby is a Bernoulli trial because you can have a boy or you can have a girl. There's 2 outcomes, right? But throwing a dice, even though there's 6 outcomes, right, it still can be fitted in here because if you want to know how many 6s you're going to get, you can get a 6 or not get a 6, okay? Right? So you have to, there's 2 outcomes, right? There's no thing as, oh, how many 6s can I get and how many 5s can I get and how many 4s can I get? It's get a 6, not get a 6. It's a head, it's a tail, right? It's a boy, it's a girl, right? There has to be 2 outcomes, right? If it's playing basketball, it's score a basket, miss, score and miss, right? 2 outcomes. And we call one of them success and one of them failure. Which one do you call success and which one do you call failure? The one you're looking for in the question is normally success. So if they ask you, how many heads did you get? Head is a success, tail is a failure, right? If you're talking about having babies and they want to know how many girls, a success is having a girl, obviously, right? And a failure is having a boy, obviously, right? Okay, so you call one of them success and one of them failure, right? Okay, so 2 outcomes, one is success and one is failure. This will make more sense when we do an example in a minute, okay? The trials are independent. That means the results of the first trial cannot influence the results of the second trial, right? So, for example, if you are tossing a coin, it doesn't matter what you get in the first toss, the second toss, it's not going to affect the result of the second toss, right? Whereas before, when we were picking balls from a bag, if you don't put the ball back, it'll affect the second, so we can't, they have to be independent, right? The results of the first cannot affect the results of the second. The probability of success and failure is the same for each trial, right? So the probability of success or failure is the same for each trial. So the probability of a head in the first one is a half. The probability of getting a head the second time you toss it is a half. The probability of getting a head the third time you toss it is a half, and so on, right? The probability of a head is always a half, okay? If you're throwing a basket and the person throwing the basket's chances, they score 1 in 5. So their probability of success is 1/5 the first time they throw it. The probability, hi.
Can I speak to Leah Sultan for a second?
She's not in today.
Okay, thanks.
The probability of success the second time round is still 1/5, okay? So the probability doesn't change from trial to trial. Get that? Right. And the last thing, there are a fixed number of trials. So they have to tell you how many trials there are. So there's 10 trials. You do it 10 times. You do it 5 times. You do it 100 times. right? It doesn't matter how many times, as long as they tell you. So it's not, you keep going until you get a 6. You throw it 10 times, and how many 6s do you get, right? Is that okay? So there's a fixed number of trials, right? It's not open to interpretation, right? Okay? So they're Bernoulli trials, okay? I'm going to, again, this won't make this will make more sense when we do an example. So I'm just giving you the theory to write down, and then we'll do an example. Is this down? Is it down, Nate? Yeah. I'm asking you because you're always last. So if you're done, everyone's done. Right. That's not a bad thing. It's just an observation. Right. In a Bernoulli trial, we normally call P success. When we come on and see a formula in a minute, there'll be a P in it. So the P stands for the probability of success. So if you're tossing a coin and success is a head, you want to count the heads. So success is a head, so P is a half. Right? Q would also be a half. Right? Okay? So if your chances of scoring a basket is 1/5, the probability of success would be 1/5. Q is the probability of failure, so Q would equal to 4/5. Okay? So we use the letters P and Q in the formula that we'll see in a while. Okay? So P is the probability of success, Q is the probability of failure. Okay? Now, there are a couple of different types, girls, of questions that we use Bernoulli trials in, right? We're going to do 2 types today. There's 3 types in total. We're going to do 2 types today, okay? So the first type is, right, when will you get your first success, right? For a single trial, okay, the probability of success is 0.4. Find the probability that the first success occurs on the 4th trial. So this is a Bernoulli trial. How do you know? Because you can only success and fail, right? The probability of success is always 0.4, so it never changes. The probability of failure is 0.6, never changes. There's a set number of trials. There's 4 of them. So whatever, they don't tell me what it is, but you do it 4 times, okay? So we know there's success and failure. We know they're independent, as in it's always 0.4 for success. There doesn't change, right? It's independent, and there's 4 trials, okay? Right? So how we do this is, for type 1, for when you want the first success, so you want to do it 4 times. So what do you want to do the first time you do it? What do you want to do? Do you want to succeed or fail? For the first time, you want to fail, don't you? Because you want to succeed on the 4th one for the first time. Then on the 2nd time you do it, what do we want to do? Fail again, right? And the 3rd time you do it, what do you want to do? Fail again. And the 4th time you do it, what do you want to do? Succeed, isn't it? Right? So there's nothing new in this one. We'd be able to do this one without knowing about Bernoulli trials. Okay? So we want the first time you succeed, we want that to be on the 4th trial. So that means we want to fail first, fail second, fail third, and succeed on the 4th. Right? What? Push it over a little bit, sorry. Push me over a little bit as well, and then, right. What's your chances of failing, please? 0.6. And means you multiply. What's your chance of failing? 0.6. And means you multiply. What's your chance of failing? 0.6. And means you multiply. And what's your chance of succeeding? 0.4. So into the calculator with all of those and get an answer. 0.0864. So that's your probability of succeeding on the 4th go. Is that alright? That one's easy enough, that type, isn't it? Because you want to do 4 trials, and you don't want to succeed, your first success. You want your first success on trial number 4. So in trial number 1, that's what the question asked me. In trial number 1, you want to fail because you're not allowed to succeed because you don't want to succeed until the 4th one. So if you don't succeed, you fail. So you want to fail on the first, fail on the second, fail on the third, and then succeed for the first time on the 4th. Okay?
Why do you know it's 0.2?
Because they tell me the probability of success is 0.4, so therefore fail is 1 take away 0.4. Right, I'll do a second example. Right, you want to throw a dice. And find the probability.
Type 1.
Yeah. Probability of getting the first 6 on the 5th right, so you want to throw a dice, find the probability of getting the first 6 on the 5th throw. So what success, please? Success is getting what? Getting a 6, isn't it? So success is getting a 6. So what's the probability of success? 1 over 6, isn't it? You have a 1 in 6 chance of success. Would you agree? Right? What's failure? What's failure? Is getting any other number except a 6, isn't it? So what are your chances of failure? 5 over 6, because you have 5 chances of getting a number that's not a 6. Okay? So success and failure. So it doesn't matter what the other numbers are, right? It's just a failure. And you have 5 chances of failing, you have 1 chance of succeeding. So you want to throw the dice, right? And the first time you want to know what's the probability of getting the first 6 on the 5th throw, right? So you want to, your first throw, do you want to succeed or fail? Fail. Second throw, what do you want to do? Fail. Third throw, you want to fail again, don't you? Fourth throw, fail again. And the last throw, you want to, 6th throw, or the 5th throw, you want to succeed. So you want to get the first 6 on number 5. So no 6, no 6, no 6, no 6 at 6. Okay? So then fill in your probabilities there. So failure is 5, 6, and means you multiply. 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 And finally, success 1/6. Okay? So into the calculator with that, 5 over 6.
Do you want the answer?
I do.
0.0800.
Yeah. 0.08030. I'll round it up. It's 0.37, so I'll just round it up. Is that right? Okay. So your probability of getting your first 6 on the 5th row is, there you go. We all right? So will I do type 2? Actually, do you want to just try one of those before I do type 2? So if we do, I'll put it up now on the camera now in a minute. So just so you know, you're doing page 20, and when I turn the page, I'll be able to tell you what page it's on. page 2 of 9, question 1. Right, and here it is. I'm not putting it up in picture, I don't need to, because we'll have it done in 2 seconds. Can you read that? Not anymore. Can you read that? No, because it's... Uh-huh. No, number 1. Done? Did you get 0.0964? 0.0965 actually, when you round it up, but anyway. Are we all okay with that?
How come those that is back to go then, that's 135 over?
Yeah, they just gave your answer as a fraction, so if you give it as a fraction, it's 125 over 1296. They give their answer as a fraction in back to go, do they? Right, okay, type 2, so type 2 has a formula, okay, so, sorry, it's all, so type 2 is when you're looking for the exact number of successes in n trials, okay, and that's called the binomial distribution. Okay, so the probability of how many successes will you have? So if you throw the dice 10 times and the success is getting a 6, right? What's the probability of getting 4 6s, right? So the probability of getting 4 6s is n choose r, that's our combinations that we learnt in the last chapter. P is the probability of success to the power of r, and Q is the probability of failure to n minus r. Now, it's in that formula is in the tables on page 33, so you don't need to learn it.
Miss, does that say if there are more successes in n trials?
Yeah, in n trials. So again, they're going to tell you how many trials. They have to tell you, that's part of, you can't use Bernoulli's rule or laws unless they tell you a set number of trials.
What's R then?
Or is how many successes you want. They will tell you in the question. Okay? So again, it'll make more sense when we do the example.
Oh, can you push it?
Oh, sorry. Where am I going?
Oh, yeah, okay.
Yeah.
Is it n choose or?
N2s are, yeah. N2s are. So our combinations are coming in here.
is the successful, right? And the two examples from type 1.
And type 1, no, I think one was the fourth row and the other was the fifth row. Was it?
Oh yeah, sorry.
Yeah, is that right?
Yeah.
They'll tell you which number in the question. Okay. Right, okay, this one, right, so a dice is thrown, right, okay, 8 times, so they told me what n is. N is the number of times you've done the trial, so n is 8, is that okay? Right, what is the probability that we get exactly 2 6s? So, I want 2 6s, so R is 2. Would you agree? R is 2. Why? Because they tell me I want 2 6s. So I want to throw it 8 times and I want to get exactly 2 6s. Okay? So R is how many successes you want. Success is getting a 6. So what's the probability of success, please? 1/6. And Q is the probability of failure. So what's the probability of failure? Which is not getting a 6. 5/6. Would you agree? Okay, so then you're just filling in the formula. So the probability of getting 2 6s is equal to n choose R. 8, n is the number of trials, R is how many 6s you want to get. Okay, so it's 8 choose 2, right? Then it's P to the power of R, so that's the probability of success to the power of how many successes you want. I want 2, right? And then failure, 5/6 to the power of how many failures do you want, basically, right? So if I want 2 successes, how many failures, and I'm doing it 8 times, how many failures do I want? 6. And into the calculator with that and press equals. Okay? So it's n choose R, so that's 8 NCR 2, right? Multiplied by 1/6 squared multiplied by 5/6 to the power of, oh, I don't know what I did there, to the power of 6 equals, I'm looking at 0.2604, now I could have typed in something wrong there, 0.2605 when you round it up. Okay, so what's the chances that you're going to get 2 6s when you throw a dice 8 times? Right, what are your chances of getting 2 6s anywhere? So you get the 6 in the first row and the second row, you get the 6, 1 in the first row, 1 in the 7th row. So we haven't pinpointed where exactly we're getting the 6. We're just throwing the dice 8 times and we're working out what are our chances of getting 2 6s anywhere in those 8 rows. Right? I'll do type 3 tomorrow. I'm going to give you some of those. So page 210, let's do 3 to 10 for homework. So page 210, 3 to 10.